I decided to do my presentation on user credential protection. Alright, so basically when you create an account, I'm pretty sure all of us done, you enter, the necessary text boxes, you follow the necessary confirmation email, the text boxes, and then the text boxes give you an idea what to fill out, and then usually you have a password, and they'll tell you to put numbers in your password to make it longer and all that other annoying stuff. And then after you finish all of that, the website will send you a confirmation email. All the usernames and passwords are usually stored in a database such as SQL and Oracle. I'm pretty sure the password and usernames are stored once you click confirm, or once you confirm your email. Alright, so there's a couple of security measures that are used to protect these usernames and passwords once they're in the database. Yeah, the plain text was barely no security at all. We had an issue in 2011 where Sony actually had all the username and password in plain text, and the hackers were back today, and they had to do no find out what the passwords were. So they had all the username and password at their disposal. I mean, passwords, you had cards, you had everything. You have just about everything on someone's account. You have access to their account. So that's not a good idea. If you're going to be a database, if you're going to use a database to store passwords and username, do not use plain text. It is a no-no. You have encryption, which is what we went over all this semester. Everybody has an idea what encryption is. It's basically encoding the password, encoding a message, having a key to be able to decrypt it, and so forth and so on. And hashing, which is basically a one-way function algorithm, which I will discuss later on. They can turn any data into a fixed length fingerprint that cannot be reversed. So the thing about hashing is that it cannot be reversed. That's what makes it so reliable and safe. And then you have salt, which is used with the password. It's basically a randomized sorted string that can be used with the password to make it more secure. Alright, encryption is probably the easiest to break out of the three besides the plain text, and is not the most favorable to use. Mainly because that if it's encrypted, it can be decrypted. We know that it can be reversed. For example, I have an example here. You have 7 plus 3 is 10, and then we reverse that, 10 minus 3 is 7. So I mean, as long as someone has the key to the encryption, they can decrypt it, therefore finding the password. You might want to stay away from this because pretty experienced hackers and cryptographers can easily break a password that's encrypted. And then you have hashing. One of the more safe security measures. It's a one-way security measure, which means that hashing is pretty much irreversible. For example, if you have 22 modulus 7 equals 1, you can't really go back and reverse it. I don't really like this example, so this is an example I thought of. This. For example, if you have, let's see, 10 plus 4 equals 14. And you have 14. It is impossible to actually find out which numbers you had to get 14. Or if there's just two numbers to get 14, you can have 2 plus 2 plus 2 plus 2 to get 14, you get what I'm saying? Or you can get 7 plus 7 to get 14. But it's infinite of ways you can get 14. It's, you know, you really have to guess which way to get it, and that's what make it kind of irreversible in a sense that you really can't use a key or decrypt how you got field 14 to begin with. But the problem with hashing that is not completely safe from brute force attacks and dictionary attacks, which mean that even if the password is being hashed in the web server, the hacker can just go on trying to guess the password. You know, or a dictionary cat just go down the dictionary and guess what the user password is. Lookup tables are also more commonly used to crack hashes. They're basically pre-computed hashes that are in a dictionary of pre-computed hashes that are put in a table, and you compare them to the hashes in the database and see if there's a match there. And there's a match, then you basically find your password. Let me see. Give you guys an idea of what exactly hashes look like. Let's see if I can use. Let's see. Let's see here. Let's make a text file called text.txt. And let's type a password here. Let's say the password is, someone give me a password. Password. Okay. So, scat, make sure I did this right. So, in the text file, you see there's password there in the text file. So if I wanted to hash this password, most Unix system has this. I haven't tested to see if this one has it, but you can hash it, and you get this. Yeah, this is basically and digest the password and then spit out this. So as you can see, it's extremely random. It's really hard to tell. Like, even if I were to do something like change one letter in password, the hash would be completely different. So let's see. Let me just put one here. Okay. That's text. Even if you change like one letter or remove one letter or add one letter, whatever, it's completely different. That's what makes it really safe. It makes it reliable, because it's really hard to see exactly what the password is. And you notice no matter how many letters I add or subtract, it's at a fixed value. Alright, so there's different hashing functions or algorithms that are used. The most popular being MD, which was originally created by Ronald Ryerson in 1989. And then, of course, you have the SHA, which is the secure hash algorithm, which is divided by the United States National Agency and the Federal Investigation Processing Standard, and which is also a Federation Information Processing Standard. It was published in 1995, and it was basically based off of MD. And here's all the other hash functions that can be used. As you can see, they're updated versions of each other. Like MD 2, 4, 5, 6 being the latest one, and SHA 1, 2, and all the rest of them. Well, I think the basic idea is that you want to use the latest one because it's the most fine. So I was wondering why the most popular hashes functions to use, because there are a lot of, as you can see, there are a lot of hash functions there. Functions go. One is uh, one is the computational efficiency. Hash functions should not take really long to digest a password, meaning that it shouldn't really take a lot of computing power to hash a password, because you don't want a lot of the web server to be bogged down with a lot of CPU power, and you don't want to lag the system and stuff like that. And collision resistance is it's difficult to find two inputs that hash the same output. You don't want your hash functions to have an instance in which there's two inputs and they input the same output. You don't want two of the same hashes. It creates a collision, and from there it's easier to exploit and find the algorithm of that hash function. It should be able to hide information, of course. I mean, you don't want the person to see their password based on the hash that is given, and it should look random. It shouldn't be a patterned or easy to figure out type of function, which you can look at it and tell which letters belong to where, and from there find out the password. And then you have salt, which is a randomized string of words or letters that are associated with the password. It is used in conjunction with hashing to further security. So, for example, you will have your password, and then you will have your salt, and your salt will be a random letter, and then your password will be whatever you selected. You put those two together, and then you hash those two. That way, it gives you a whole different hash. And then it helps negate lookup and reverse lookup tables. A person who have lookup tables will just have the raw hash, and he won't have the salt. So he'll have the hash. He might guess your password, but since it's hashed with a salt, he won't be able to find the password anywhere. So you have the CRPRNG, the cryptographically insecure pseudo-random number generator. Extremely long in there. It's basically they're programs used to generate random strings. I mean, you can find these programs in software, Java, PHP, C, C++, Python. Many other functions will provide such. So where to hash per se? Typically you want in the web server here, but some people hash in the client. But if you hash in the client, you also want to hash in the web server. But you want to hash in the web server because you want the user to it to hash, go to the domain controller, and then check in the SQL server to see if the hash matches in the SQL server, and then from there it confirm yes, and then it'll lock you in. If you were to hash in the client web browser itself, the problem is that if a person is sniffing, let's say Kathy sniffed the hash, she doesn't even have to guess the password. She can just hash and send it to the web server, which will send it to the SQL server. I think what else? Yeah, it's more safe to just hash in a web server. That way that way you can actually keep your password, and the person that sniffs it has to guess the password, has the password, but don't have the hash, and it can't be sent to the SQL server. And there are other types of hashes used called wacky and weird hashes. There, it's the use of hashes and salts within a hash. So, for example, you have MD5 hash, but within that hash you have another hash and a salt plus a password, or you can have a hash, or within the hash you have a hash password and a hash, and you hash a salt and you combine them and then hash that all together. There's endless possibilities you can do with it, but there's a lot of debates about this, heated debate about whether this is actually useful or not, because in theory if the person hacks the database itself, then they can recover the source code. The source code will have the algorithm, and it's easy to reverse engineer the algorithm, and from there they can easily just find out what algorithm you use to make a hash. But then people like to say that it would slow them down, but there's also many other more effective ways to slow down hackers than that. But that's a whole nother presentation in itself. I guess the best way to do it is to find the most efficient hash and salting software and use that rather than just finding wacky and weird hashes that will actually affect the computational efficiency of the web server. I mean, of the algorithm itself. So, that's any questions?
If you change the next password, the hash change?
Typically you want to do that. Yeah. If you change your backup password, you want there to be a new hash, and you want there to be a new salt that goes along with it. So yeah.